Hello again. In this video, we shall try to visualize the program that implements array of size 4 using the so-called physical models. So this is our program, and we are going to start analyzing the dynamic property of this particular program, starting with this line number 6 where an array is being declared, int a4. Now, with this kind of declaration, in the computer, we assume that before declaration, the computer memory looks the way we may imagine here. This is the computer memory, that is the container, array of containers which are free and they are not occupied. Now, this is before line number 6. We can say before declaration. Now, after declaration, the status will change as follows. That is, after line number 4 is executed, int a4, what we are going to see is that this particular array of containers, that is container 1, container 2, container 3, and so forth, this one and this one. This particular group of containers will be called A, for example. So this is reserved, this is reserved, this is reserved, and this is reserved. But these other two will remain empty. So this is the array A. Now, this one is going to be A sub 0, this will be A sub 1, this will be A sub 2, this will be A sub 3. So now, when we come to the data entry, C in A sub 0, C in A sub 1, C in A sub 2, and whatever, this particular scenario will change as follows. Let us assume it comes here. That container A sub 0, container A sub 1, this is empty, this is 1, this is another, and this is another. So we have said that this is A and it is arranged this way. That is sub 0, that is sub 1, that is sub 2, that is sub 3. Now with C in A sub 0, it means the computer will allow us to enter data such as 2 in this particular container through the keyboard. But now we have been using kind of physical objects. Let's say 2 have been entered there. And then if these are physical objects. So C in A sub 1, we can put another 2 there. C in A sub 2, we can put, let's say, 3, whatever, that is 3. And C in A sub 3, we can put 1 there. So this is array A. This is array A. Now, when it comes to line number 16 up to line number 19, the output from these particular containers will be reflected on the screen. So what we are going to see is 2. We will see 2 again here. Then we will see 3. That is counting 1, 2, 3. And then we will see 1. This would be the output from this particular array from emanating from execution of output lines. And this one puts us to the end of this particular video, which we can combine with another one if we abandon this particular narrative, and we bring up another part where we can visualize the same program now using RAM diagrams. So if we come to line number 6, int A4, consider that the memory before declaration is like this. This is RAM, that is computer RAM, just the same thing. For now, this memory is empty, nothing is inside. But then after declaration, this will be the status of this particular RAM. It will change, whereby we have RAM here, and then we have 1, 2, 3, 4, 5, 6, but then we have 0, 1, 2, 3, and this one would be called A. So you have A sub 0, you have A sub 1, you have A sub 2, you have A sub 3 here, and all these are reserved. But this one is now empty. It's not occupied. So that is as far as this particular line is concerned. But when we come to this group of lines, you find now C in A sub 0, C in A sub 1, the status is going to change. C in A sub 0, let us look at it. This is A, 1, 0, 1, 2, 3. So sub 0, sub 1, sub 2, sub 3, and this is array A. So C in A sub 0, enter 2. C in A sub 1, enter 2. C in A sub 2, enter 2. Enter 3. And C in A sub 3, we entered 1. Now, this is as far as data entry is concerned. Mind you, the array, this part is empty, not occupied, but this is our array as it seems here. Now, when the computer comes to line number 16 up to line number 19, C out A sub 0, C out A sub 1, it means output from this particular array will have to be thrown on the screen. So we will see 2, 3, and 1, just as we could see from this compiler here, that if we come back here, and if we come back to the program, if we compile it, and if we run it, we could say now, I enter 2, I enter 2, then I enter 3, I enter 1, and here we are. So you can see now, this is how this program can be visualized or interpreted in case you want to use any of these visualization means. For now, one can say thank you and bye-bye for listening.